Hello, and welcome back to your second functions lecture. So in the last lecture, we talked about functions, how to define them, how to call them, and how to give them arguments. Arguments, remember, are things that are coming into our function from the person calling them that can change every time we use it. So for instance, in that print name function that we had, we could change the name of the person that we're printing every single time we call the function. Whatever we give to the argument when we call it is what's going to be used when we run that function. So far, what we've done when we have an argument is just put the name of the argument in the function and expect that our user who's going to call the function is going to provide whatever object needs to go with that argument. However, if there's ever a case where you want to provide a default option in case the user doesn't specify what argument to use when calling the function, you can do that by using a default argument. To define a default argument, you're going to say inside the function definition, the argument as usual, and then you're going to put an equal sign and then the default value that you want to use for that argument if your user does not provide a value for that argument when calling the function. Let's go to Atom to see some examples. Okay, so let's define a function called menu printer, and it's going to have an argument item, which is going to be the menu item that someone orders at a restaurant. Our function is then going to print you're having the plus the name of the item plus today, make sure you put a space, enjoy. So this function basically takes in whatever the person is going to be eating and prints out you're having the whatever they're eating today, enjoy. Now, we can set a default for this argument. So if someone doesn't specify what item it is they're having, we can just make an assumption. So we can say the default item is going to be the string turkey sandwich. So this means that if someone doesn't specify what item they're having when calling the menu printer function, Python will assume that that value is turkey sandwich. Let's go ahead and test this out. So if we call menu printer, now normally we would say, well, there's one argument, it's the item, we have to give it item. Well, actually with a default argument, we don't. We can call the function with no arguments inside of it, and it'll just use the default value. So let's go ahead and try that. I'm going to say Python 3 functions 14 blank. There we go. And let's go ahead and run this, and it says you are having the turkey sandwich today, enjoy. So you can see that if we don't specify what the argument item should be, Python will use the default argument that we gave it. However, this doesn't mean that we have to use turkey sandwich. For instance, we could say menu printer impossible burger. So I'm having an impossible burger today. When I run this, you can see that it'll print out impossible burger. So you can override the default argument, but the default is just there so that you can have something to fall back on if the user doesn't give you a value for your argument. All right, so far we've just been giving Python an object inside the function as an argument, but we can also use what's called named arguments. Remember, our arguments have a name that we give them when defining the function. So instead of just saying impossible burger inside the function, we could say menu printer item, the name of the argument, equals and what we would like it to be equal to. So in this case, I'll say eggplant Parmesan. Okay, so this is basically the same way to do what we did on the line above. Just instead of assuming that it was for item, we explicitly told Python the item argument we want to be equal to eggplant Parmesan. Let's go ahead and save and run. Beautiful. So you can see there are multiple ways of calling functions that we define in Python when giving them arguments that have a default. Now, you might be wondering, why would I go through all of the trouble of saying item equals if I could just say the string that it is? Well, let me tell you. We are often writing very simple functions so far in this class. However, functions can take in multiple arguments, all which have their own names. For instance, let's define the function 3things, which takes in 3 strings, thing1, thing2, and thing3. So now this function has multiple arguments. We're going to print out, here are 3 things I love. we're going to put a new line. We're going to say plus thing 1 plus a comma plus thing 2 plus another comma, and then plus thing 3. So this function is basically going to take input of 3 strings, which represent 3 things that we like, and it's going to print out, here are 3 things I love, and print them out. Now let's go ahead and give thing 3 a default argument, because maybe it's really hard for people to think of 3 whole things that they love. So we'll give it the 3rd argument default is you. All right, just because we gave something a default argument doesn't mean we have to use it. So let's call this function 3 things and give it eggs, butter, and lamps. Now let's go ahead and comment out this code from before and run. So you can see that it prints out, here are 3 things I love, eggs, butter, lamps. We can also call our function by relying on the default argument for thing 3. We could say 3 things, but only give it 2 things. We'll say the sun and jelly, and not give it anything for thing 3. Remember, if we don't give Python a value for an argument that has a default value, then it'll go ahead and just use that default value. So when we save and run this, it says 3 things I love, the sun, jelly, and you. Now, the nice thing about named arguments is that we can specify them out of order. So far, when we have multiple arguments, we've just been giving the objects for those arguments in order. So this is thing 1, then thing 2, then thing 3. However, with named arguments, we can go ahead and specify them in any order that we want. So let's say 3 things and say thing 2 equals John Mulaney. Thing 3 equals black licorice. And then thing 1 equals jam. So see, we've given it all 3 arguments, but out of order. But that's okay because we've specifically told Python which item goes with which argument. So when we run this, we can see that it put them in order. Thing 1, jam, thing 2, John Mulaney, and thing 3, black licorice. It can also just help us keep track of things. For instance, let's say 3 things, and we'll say olive oil, that'll be thing 1. And then we'll say thing 2 equals blood. Now we haven't given it an argument for 3, but that's okay because there's a default argument. So when we run this, it's going to say, I love olive oil, blood, and you. Giving Python functions arguments in order is fine, or with named arguments, or even a mix of both, but you're always going to be putting the unnamed arguments, so things like olive oil, first, and then later putting the named arguments if you have any. Let's really quickly experiment with this by copying our function, and we're going to comment this out. And instead of just having thing 3 having a default item, let's have all of them have a default. So we'll say sunshine. Thing 2's default will be water, because we all need water to live. So now we could actually call the 3 things function, 3 things, with no arguments, because every argument needed for the function has a default. So when we do that, it says 3 things I love, sunshine, water, and you. Now here's where named arguments can really shine. Let's say I do love sunshine and I do love you, but I don't love water. So I'm going to say thing 2 equals orange juice. Okay. So this is really helpful because instead of having to list out the defaults again, I can simply go, I only want to change item thing 2 to be orange juice. And when I run this, you can see that it's exactly what it does. It still uses the default for thing 1 and thing 3, but it changed thing 2 specifically to be orange juice. All right, let's do some more function practice. We're going to create a function called store that takes in the arguments shirt price, shirts bought, shoe price, shoe bought, socks price, and socks bought, and the tax. We're then going to use these to create a function that calculates a customer's total. So say our store only sells shirts, shoes, and socks. We're also going to give defaults for all of our arguments, and then we're going to practice calling our function using those defaults and also overriding them. Okay, so first let's define our function. We're going to say def store, that's the name of our function, and then we're going to give it 7 arguments. First we're going to say shirts price, then the number of shirts bought. We're going to say shoe price, shoe bought, socks price, socks bought, and finally the tax rate. We're going to put a colon and then indent, and this is going to be the code that will run when we call our function. So we wanted to calculate our customer total. So we're going to say total equals, and we're going to say shirt price times the number of shirts they bought, there we go, plus shoe price times shoe, can't spell, there we go, bought, plus socks price times socks bought. And I'm going to go ahead and put parentheses. So that's going to be their total merchandise. Then we're going to say total, there we go, total equals total times 1 plus tax. So we're assuming that tax is coming in as a fraction here. Then finally, we'll return this value so that we can store it later. All right, now the prompt said to give default values to each of these arguments. So we'll say shirt price equals $7.99. Shirts bought, we'll say 0. I'm going to hit enter so that we can better organize this and see it. We'll say shoe price equals $20.99. Default for shoes bought will be 0. And then we'll say sock price default is $2.99. Socks bought equals 0 as a default. And finally, the tax will say tax equals 0.08%. All right, so we have our function. And again, nothing's going to happen when we run this because we haven't asked Python to call the function. To do that, we could say store, and I'm just going to call it with all of my defaults. So let's go ahead and make sure we print that out so we can see the output and run. Awesome, so you can see that our total price is $0 because the defaults for shirts, shoes, and socks is 0. So we basically bought nothing. All right, so let's pretend that this time we've bought 2 pairs of shoes. So we're gonna say shoe bought equals 2. And you can see how named arguments come in handy here, because instead of having to list out every single of the 7 arguments for this function, we could simply use the default for all of them and just change the one that we wanted. All right, so when we run this, we can see that our price was about $45. So we paid about $45 for 2 pairs of shoes. We can also, by the way, change multiple named arguments at once. So say that we still bought 2 pairs of shoes, but there was a sale. So shoe price is actually $15.75. Now, when we go ahead and run this, we can see that our shoes were a lot cheaper at only $34.02. All right, let's write another function just for practice. We're going to write a function that is going to count the number of uppercase letters in a string. So we're going to say def upper counter, and it's going to take in a string, and we're going to give it the default, the quick brown fox. All right, give it that colon, indent under, and now we can write our code. So we're going to start our counter off at 0. And then we're going to say for letter in S, that's our string, if letter dot is upper, count plus equals 1. And then at the end, once we've looped through every single letter, I'm going to go ahead and return the count. So remember, we've given Python instructions, but we've not actually asked it to do anything. We can do that by calling our function. So we'll do that by saying upper counter, and let's go ahead and call it with just our defaults. I'll go ahead and comment out the old code, and let's run this. Great, so it actually did run, but I should probably print out the output for us to see, so let's go ahead and do that then. Beautiful. So this said that in our default string, the quick brown fox, there were 4 capital letters, which is true. There's this one, this one, this one, and this one. Again, we can also call it with another argument that's not our default, so we could say hello. And when this runs, it'll count the number of uppercase letters, which in this string is 5. Again, we could also call it with a named argument, so instead of just saying hello, we could say s equals hello. And in fact, let's change it to be helicopter. And when we run this, you can see it has 10 capital letters. All right, one more. We're going to define a function that tells us whether or not a number is prime. So we're going to say def prime, and then it's going to take in just n, which is a number, and we're going to check if it's prime. Well, first, let's hard code the first two cases, 1 and 2. So we'll say if n equals 1, return false. Elif n equals 2, return true. Now, for any number that's not 1 or 2, we actually have to check if it's a prime number. So we'll say else. And the way that we check that a number is prime is to check if it has any divisors other than 1 and itself. So we can say for x in range 2 to n, this will check every number from 2 up to but not including n. And we'll say if n modulo x equals 0, in other words, if n is evenly divisible by x, then we know that we found a divisor, and that means that our number can't be prime because it has a divisor that's not itself or 1. So if we find one, we can return false. And just as a note, the return statement sort of works like a break here, because once we hit a return, our function stops running. It will not check anything else or do anything else. A return is this function's done. Now, if we can get through the entire for loop without triggering this return statement, that means that we haven't found any divisors, which means that our number is prime. So if we get through this, then we're going to say return true. Beautiful. Now that we have our prime function, let's go ahead and test it out. So we haven't actually asked Python to do anything yet, so let's go ahead and call our function. We'll say prime, and let's just check 1 because we hard coded that, so hopefully that'll work. And let's print out the result so we can actually see it. All right, so when we do this, it returns false because 1 is not considered a prime number. How about if we check with 3, which is a very small, but we know it's a prime number? Well, when we run that, it returns true. How about with 13, which we know is another prime number? Also returns true because that's prime. How about 12? We know 12 is larger, but it is not a prime number as it has a divisor like 6 or 3 or 4. So let's go ahead and run that, and it returns false because 12 is in fact not a prime number. All right, I hope all of that function practice helps solidify some of these ideas. That's all that I have for you. I will see you next time.